All right, and welcome back, chemistry students. So today we are going to continue talking about our solutions, and we're going to talk about making diluted solutions. Okay, so before we were talking about preparing a solution. We know that molarity is equal to the moles of the solute over the liters of the entire solution. Okay, and so we talked about how we can make that solution by solving for the moles first, and then we can take those moles and we can convert them to grams, and we can say, okay, we got to dissolve that many grams in our solution and make sure we've got it filled up to the proper volume. Okay, so what I want to do today is I want to talk about if I've already got a solution made, if I want to make other solutions from that, right? That's called making a dilution. Okay, so we always start with something that's going to be a higher concentration, and we can dilute it to make other solutions of smaller or lower concentrations. Okay, so when I do that, okay, we are making our dilution, and if you take a look over here at this picture of the two beakers, okay, aside from the fact that these two beakers are different sizes, right, that doesn't really matter all that much, okay? But what I'm more concerned about is taking a look at those two solutions, right? I'm going to call them solution A and solution B. Okay, solution A, I would say this one is more concentrated, right? And solution B is going to be less concentrated, or we could say this one is a dilute solution. Right? How do I know that? Well, by looking at my diagram here, I've got the light blue with representing the water for my solvent, right? And then I got these yellow dots in each one, right? And those are representing my particles of solute. Okay, so just visually looking at this, I can tell that B is more dilute because there's more space between those particles, right? There's a lot less space. In A, the particles on the left are much closer together. Okay, so we say they're more concentrated. Right? Now, taking a look at A and B, right? So B, this one has more volume. Okay, but let's take a look at the yellow particles. So if I count those up in A, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, 13 solute particles here. Right, and B, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I have 13 solute particles over here as well. Okay, so I am not changing how much solute is in here. What I'm changing is I have more solvent. Okay, so whenever we make a dilution, what we're going to do is we are going to add more water to that. Okay, so it's going to increase my volume, and that's going to lower my molarity. Okay, but the thing that's always going to stay the same is going to be the number of solute particles. Okay, so just to reiterate, okay, for a dilution, right, our volume is going to be increasing. That means my molarity is going to be decreasing, right? But the moles of solute, those are going to stay the same. Okay, so moles of the solute don't change. Okay, so we can use this to our advantage if we want to do some calculations, right? Figure out what's the concentration of my new solution and that sort of stuff. Right? And that's going to be this formula down here. Right? So whenever I have a dilution, I'm going to be using this M1 V1 equals M2 V2. So this is my original solution over here on the left-hand side, so my starting solution. Okay, and M2V2 over here on the right, this is going to be the dilution that we make. Okay, so if I take a look at this, think about my molarity formula. Molarity is moles over liters. Okay, if I rearrange this so that I have molarity times liters or molarity times volume, that equals my moles. Okay, so remember, we said that in a dilution, the moles of solute, they don't change. Okay, so when I take M1 times V1, that'll give me my moles of solute. M2 times V2 gives me moles of solute. Since moles of solute don't change, that's why these two are equal. Okay? So let's take a look and see how would we be using this. Okay, so let's come on down here to number 6. All right, I want to know what volume of a 16 molar sulfuric acid solution must we use to prepare 1.5 liters of a 0.1 molar sulfuric acid solution. Okay, so I'm starting off with my 16 molar, and I want to prepare a 0.1 molar, so it's going to be way diluted. Okay, 16 down to 0.1. So I need to know how much that 16 molar I need to use. Okay, so I'm going to go ahead and I'm going to just write out what all these variables are. I'm doing a dilution, so I know I'm going to use that M1V1 equals M2V2. So I'm looking for a volume. All right, so I'm just going to put V here for right now. All right, I want the volume of the 16 molar sulfuric acid. So 16 molar, that's my molarity. This is the bigger molarity. This is my starting molarity, so I'm going to call this M1. Okay, coming back to that volume, right, I want to know how much of that 16 molar sulfuric acid I need, so that's going to be my V1. All right, now the solution I'm trying to make is going to be the 0.1 molar, so that's going to be my M2. That's my new solution, and I want 1.5 liters of that, so that's going to be my V2. Okay, so now I've got everything labeled. I know what I'm looking for, so I can plug into my equation. So I'm going to do 16 molar times V1 equals 0.1 molar times 1.5 liters. All right, and I can divide both sides by that 16 molar. All right, so that's going to cancel out here. I can solve for that V1, and that's going to be 0.0094 liters. Or to make it a more reasonable number, right, if I move that decimal 3 spots to the right, that would give me 9.4 milliliters. Okay, so what this is saying is if I want to start with this 16 molar sulfuric acid, I'm going to measure out 9.4 milliliters of it. I'm going to put it into a new container, and I'm going to add water to it until my total volume is 1.5 liters. When I have that 1.5 liters, then I know my new concentration is going to be this 0.1 molar. Okay? So, a couple of things. Number one, when we're using this equation, first things first is always make sure that your units match up. Okay? That's especially important with the volume. Okay? I got liters here, so when I solve, I'm going to be solving for liters. Okay? And when I use this equation, I don't have to be in liters. I could use milliliters here, right? But then when I solve, I would be solving for milliliters as well. Okay, so just make sure that your units must match up. Okay, so make sure the units match up. Second thing, probably the number one thing that students get mixed up on is making sure that we're pairing up the proper volumes and molarities, right? So M1 and V1, making sure I'm pairing this up with the unknown, not pairing up 16 with the 1.5, right? This is for the new solution, right? I'm trying to find how much of the original solution. Okay, so those are probably the two biggest things to look out for: units and matching up M1 and V1, M2 and V2. All right, let's take a quick look here at number 7. Right? What is the molarity of a solution if I take 15 milliliters of 6.9 molar copper nitrate and dilute 100 milliliters? Okay, so this 2, it's underlined, it's bolded, so that means this is my final volume, right? So when we're all done, we're going to have 100 milliliters. So that's going to be my V2. All right, so over here I got 15 milliliters. That's my V1. Okay, and I'm starting off with 6.9 molar, so that's my M1. So we're going to be taking 15 milliliters of the 6.9 molar copper nitrate, and I'm going to add water to it until I reach a total volume of 100, and I want to know what's that new concentration. Right, so we can do this. Right, we're going to plug it in, 6.9 molar times my 15 milliliters equals M2, my new concentration, times 100 milliliters. Okay, so my volume units, they match, so we're good there. I'm ready to solve for M2. Okay, and if we plug that in, divide both sides by 100, right, we should be able to solve for M2, get 1.04 molar. Okay, so we can use it to find out how much of a volume I need to make a solution, like we did in number 6. I can figure out what's the new concentration of a solution, right, like we did here in number 7. Let's do one more together, and then you guys can practice a couple of these, try them out on your own. Okay, so on the next page, we got number 8. All right, I got 0.5 liters of a 5 molar stock solution of HCl. That's being diluted to make 2 liters of a solution. And it wants to know how much HCl in grams is in this solution. Okay, so we're starting off. I've got my original volume. I've got my original concentration. I've got my final volume. Oh, that's V2. Right? And we don't have our final concentration. Right? But it's not asking us for that, right? It's asking us how many grams of HCl there are. Okay, so remember, when we use this M1V1 equals M2V2, the moles on either side are going to be the same. Okay, so since I already have M1 and V1, I can find my moles using those. So I'm going to plug in 5 molar equals X moles over 0.5 liters. Okay, so plugging in X, I've got 2.5 moles. So I know how many moles there are. So then finally, I just need to take those 2.5 moles of HCl, and I'm going to multiply it by my molar mass, 36.46 grams over moles. All right, and we should be getting 91.15 grams of that HCl. Okay, so why don't you try out 9, 10, 11, pause the video, and then when you're done, you can unpause and we'll go through those together. All right, let's take a look at number 9. We have a 1 liter 0.125 molar aqueous solution of table sugar. I want to dilute the solution to 0.05 molar, right? So it's asking, what do we need to do to make this solution? Okay, so over here, I have my starting concentration. There's my M1. I have my starting volume, right? And I want to dilute this to make it a 0.05 molar solution. So that's my M2. Okay? So essentially what we need to figure out is how many milliliters or liters are we going to add in order to get my concentration from 0.125 to 0.05. Okay, so we can use our M1 V1 equals M2 V2. So 0.125 molar times 1 liter equals 0.05 molar times V2. V2 comes out to be 2.5 liters. So this is the total amount. Okay, so if I want to know how much I need to add to make this dilution, okay, I've got a final volume of 2.5. I'm going to subtract from that the 1 liter that we started with, right? So I need to add 1.5 liters to that 1 liter of the 0.125 molar solution. Okay, then that should give me my diluted solution. All right, taking a look at number 10. Right, how could you prepare 350 milliliters of 0.4 molar NaCl using only a solution of 2 molar NaCl and water? Okay, so this one's a little bit trickier because things are getting reversed. Okay, over here, this is our diluted solution, and this is our original solution. So this is M1, here's my M2, and this is my V2. So I need to figure out how much of that original solution do I need. Okay, so I can plug in 2 molar times V1 equals 0.4 molar times 350 milliliters. Solving for V1 gives me 70 milliliters. So I need to have 70 milliliters of that 2 molar NaCl solution. Okay, so I would say we would measure 70 milliliters of the 2 molar solution, and you can abbreviate solution SOLN like that. Right, and then we're going to add water to a total of 350 milliliters. Okay, so 350 milliliters total. Right, and that's how I would describe that one. Right, that tells me how much of the original one to start off with and how to make it into that diluted solution. All right, last one. You have 500 liters of 12 molar HCl in your closet. You're given 1 liter volumetric flask. How would you make 1 liter of 0.1 molar HCl solution? Okay, so this is the solution we're trying to make. So this is going to be my M2. All right. I've got my 12 molar HCl. Okay, so that's my M1. That's what we're starting off with. All right. I only have a 1 liter volumetric flask, so my final solution is going to have to be 1 liter. Okay, so let's call that V2. So we need to figure out from this 500 liters, how many of those do I need to make my new solution? Okay, so I'm going to start with that 12 molar. I don't know what V1 is, and that's equal to my 0.1 molar times the 1 liter. So solving for V1, okay, I'm going to need 0.0083 liters in order to make this dilution. Okay, that's approximately 8.3 milliliters. Okay, so I'm going to measure 8.3 milliliters of the 12 molar solution. All right, that'll be first, and then second, I'm going to add water to a total 1 liter volume. All right, and that's how I'm going to make my dilution there.